Hello everyone, my name is Paige Bailey and I'm here to tell you all about maps after a very short delay. So I hope you're all enjoying PyTexas in lovely College Station on this beautiful Saturday morning. Just as a short intro, I recently graduated from Rice University in May 2013. I had a bachelor's degree in geophysics and I'm going back to get my master's in subsurface geosciences. So still doing the school route, still love the earth sciences. And I'm also working full-time for Chevron in Houston. So there I do geological and geophysical applications. That's basically just taking care of all of the earth sciences software that our geologists and geophysicists use to interpret the subsurface and tell us things and potentially find oil. Well, hopefully find oil, right? So we use Python a little bit there. It's primarily for scripting purposes, so sysadmin tasks, and then also an integration with ArcGIS. And ArcGIS is a mapping utility that is proprietary, and I'm not going to go much into it today, but I am going to tell you about an open source alternative that is completely free, curated by people like you who are excited and enthusiastic about C++, Python, and all the rest, and tell you how you can get involved if you'd like to do so. So let's get started. There are 3 W's of geography. So what is where, why is it there, and why in particular would I care, right? And GIS helps us answer those questions. So GIS stands for Geographic Information System, but it also stands for Geographical Information Science, or Geospatial Information Studies, or some combination of the 3, depending on who you talk to, and depending on who wants to sound more important. So when you talk to somebody in industry about GIS, the first thing that's likely going to pop into their mind is software, right? So we're using ArcGIS, or we're using this GIS solution to map something. So they could have very differing opinions about it. But in reality, GIS is an ecosystem of computer software, hardware, and data, and the personnel who are able to manipulate it. So it incorporates a spatial location, information, system, and people. And what you're really after are not static maps, right? Like you don't want to just create something that will be used once. You want to create something that will be dynamic, that is constantly evolving, and as you incorporate more data into your system, it shows you how that data has changed over time. Or if you have different questions that you would like to answer that have a spatial component, you're able to use a GIS map to help you answer those questions. So a GIS is also not a global positioning system, so those nice little trackers that you have on your phone, they do help display on a map, but it has nothing to do with GIS itself. And it's also not a specific software package or a static unchanging map, like I said. And there are estimates, this is thrown around the geospatial community all the time, but there are estimates that 80% of all data ever accumulated have some sort of geospatial component. So some sort of way to say, hey, at this location, this thing happened. And the estimate comes from a German paper that has been translated once into English, maybe. But if you'd like a link to that afterward, just let me know. So part of the reason that GIS is so powerful is when you look at something like this, right? And this is an example of an Excel spreadsheet with geologic data. So it's telling you something about lithologies at particular locations and porosities and permeabilities of those lithologies or something. So if you look at this, like, you don't really see any immediate connections, right? Like it's a table of text. It's a table of text and it doesn't really have any meaning. It can't carry any value for you. However, if you're able to map it, right, suddenly it has a great deal of value. You can see various terrains. You can see that there are obviously very different examples of these lithologies. They have point features incorporated into the terrain. So there are two types of data incorporated into GIS. There's a raster, like a grid. It kind of looks like a picture, and each pixel has a specific XYZ point. And then there's also a vector layer, which looks more like a page in a coloring book, right? So it kind of is two-dimensional. It still has that spatial component, but it doesn't carry as much information as you would see in a raster layer. If you're getting satellite imagery, you're going to have a raster. If you're just caring about the boundaries of a state, then you're probably going to use a shapefile, which is a vector file. So Quantum GIS, which we'll be looking at today, is an open source desktop GIS product. Like I said, it's curated by the community. So the reason that it exists is because of people like you. They created it, they support it, they make modifications to it, constantly working on upgrades. And it uses the Qt library written in C++ and allows integration for Python plugins and C++ plugins. I haven't experienced any development with the C++ stuff, but the Python stuff is pretty simple to use. So just some history, and I'm not sure how we're doing on time with the delay. So that 13 minutes, thank you so much. But yeah, so this is just a background of the history, and all of these slides will be placed online immediately after my talk. So they'll be pushed to my repository in GitHub, and you'll be free to access any and all of them. So some ways that GIS is used: emergency services, environmental monitoring and modeling, businesses, so very big in route optimization. In industry, it's used for transportation, communication, mining, pipelines. In the oil industry, it's huge. Like if you start looking for GIS jobs in the Houston area or in San Antonio, what you're going to be seeing are a lot of pipeline companies who want you to help with route optimization, spatial analysis, and making sure that each pipe feature has the correct attribute data associated with it. So some specific case studies would be this, and I'm sorry if the slides are a little bit wonky, but route optimization. So route optimization, some species patterns, so reptile species within the United States. Oil contamination, that's an example from NOAA. Social demographics. So the way that I first got started with Python actually was through using GIS. I had noticed that there was a little scripting, a little Python button off into the corner. When you hit it, a terminal popped up. And you were able to do things with Python within this software package that you weren't able to do otherwise. So sociology maps are a huge way that Python is used. You can incorporate US Census data into creating anything. And then also in academia, it seems like everything would be mapped. Like, so oil contamination through NOAA. You also have these gorgeous raster maps of lunar UV of the moon or Martian terrain or something like that. And that's an example of a Rice University tree map. Geologic modeling. That's a package, an earth sciences package called Petrel, if you've ever heard of it. And it uses, so GIS isn't really concentrated on three-dimensional mapping and interpretation so much, but it does help with base maps for lease data within the oil industry. Petrel. So it's a Schlumberger software package. And something that would be somewhat equivalent to it is Landmark's Decision Space Desktop and also Paradigm's EPOS. And then there are a couple of links that I was considering going to if we had enough time. But again, the slides will be available online. So you can look at them at your leisure. So Python is a good fit for QGIS because it has a readable syntax, it's implemented in many languages, and it can also be used to access tons of open source geolibraries and software. And Qt, which I will be showing you in a few minutes, is used to help build graphical interfaces for various plugins. So if you just type in Qt Creator and then a .ui file, you can have a little manipulable GUI show up that you can associate buttons with and different parts of your code. So in terms of plugins, you can create your own. You can install from a suite of public or private ones that have already been used or already been created by other members of the community. And you can use a command line terminal within QGIS to sort of manipulate shape and layer files that you've already loaded into your environment. So let's try installing a QGIS plugin. So to launch QGIS, if you're using Linux, you pop it up like that. I'm going to load a file that I've been working on. Okay, so this is a map of some park data within Texas. Obviously, you can see there are a lot of vector files. So that little icon right there off to the left is what would indicate a vector file. And that's important when you start creating your plugin. And you can also see that it's associated with a line, right? So each layer would have that associated with it. And it's pretty extensive. So this plugin was one I created, a builder test plugin. And the way you would go about it was you would go to Plugins, Manage and Install. It would take a while because there are a lot to load. And the location that these are housed within your computer would be within QGIS 2, Python, and plugins. And you can see that there are two listed. So builder test and the plugin builder. And those are the two expressed in my QGIS map over here. So. And if you want to take a closer look at builder test, you can see some of the files that are associated with it. So Qt Creator, which was what I was talking about earlier, is associated with UI files. So you can see that this is what the plugin would look like. If you launch it from QGIS itself, so you launch it, it just has a pop-up window. It gives you a list of all of the vector files that you have. You select one, so Pedernales Falls, and it has a little pop-up window telling you that the layer has that many features, right? And so the Qt Creator has that example of a plugin. Layer Combo is the name of the feature that I associated with this box. And if we click that, if we take a look at the Python code, so Sublime builder test. Okay. You can see it off to the side here. So this QGIS plugin, the code that created it was very, very simplistic. And it's standard, the first part, the class of builder test, is standard for basically all of anything that you would want to build. The only real function that you have to change is the run statement here. So we have a pop-up named PyTexas 2014. It's a layer that has that many features associated with it. You compile it and you run it, and that's about it. So I guess I just hit my time, my allocated time. If anybody has any questions, I would be more than happy to try to answer them. Any questions about GIS? Any questions about Python? Sorry about the technical mishap. Yeah. Thank you. Appreciate it.